So in this question, the first information is the perimeter of the isosceles triangle is 29. What do you mean by perimeter? Perimeter means sum of all the sides. So x plus y plus 1 is one side, and x minus 2y plus 14 is the other side, and the third side is 2x minus y plus 4. All of these three sides would add up to 29. Now collecting all the x terms, we have 2x, 3x, and 1x, a total of 6x, 1y, negative 2y, and negative y. You just think of it as cancellation of y and negative y. We're left with negative 2y, and then the constants are 1, 14, and 4, making it a total of 19, and that equals 29. Further reducing it, 6x minus 2y is equal to 19 when taken on the other side, gets subtracted, and you're left with 10. And in order to further simplify that, it's better that we get it in the most simplest form. And that is our first equation. Now remember, whatever number of unknowns we are including in our solution, we need to have at least that many equations. You may make a note of this. Number of equations should be either equal to or otherwise greater than the number of unknowns for finding particular answer. For definite answer of the unknowns, you need at least that many equations as the number of variables. Okay, now whenever you are considering such word problems or even figure related problems, now that you have two unknowns, we will translate each of these sides, each of these informations into an equation. We will try to do that. We know it's isosceles. Basically, that was our second piece of information already stated and also indicated with the italic version, italic font. So it's isosceles. What does it mean? It means that it has two equal sides. So I'll set x plus y plus 1 and 3x minus 2y plus 14 equal to each other because it is an isosceles triangle. 3x minus x minus 2y and negative y, this negative y, and then 14 take away 1 equals to 0. We have 2x minus 3y plus 13 equals to 0. Or you can write it as 2x minus 3y is equal to negative 13. And that is our second equation. Now we got two simultaneous equations. They are both linear. What we will do is solve them. And I'm going to do elimination method. In elimination method, we target one of the variables and we eliminate it first. In order to choose the target, the easier the target, the better you're working and lesser the chances of errors. So the easy target is the one which has either coefficient which is positive 1 or negative 1, and even better if you have the same coefficients. These are the easier targets. If they are not available, then we will have to make changes in both equations. But by considering these, we will have to make change in only one of the equations. As you can see here, y has a positive negative 1 coefficient. So if I just multiply this equation, I can get the same coefficients. Now the trick is for elimination method, whichever you are choosing as your target variable to be eliminated first, it should have the same coefficients and different signs. I can see this is negative and this is also negative. In order to make them different, I will multiply with them with the negative value. The LCM of these two numbers, 1 and 3, is simply 3. So I'll multiply with the LCM here. It's multiplication with -3. That makes it -9x, positive 3y, and -15. Let's call it equation number 3. I'm going to write equation number 3 here. -9x plus 3y equals to -15. Now, if you consider these two equations and you add them, positive and -3y cancel out. -7x is on the left side and -28 is on the right. Simplifying it further, you divide by -7 to get your subject x, which is positive 4. If x is positive 4, that's all the difference in all these approaches. Now that you got the value of x, you can use any of the equations. Let's say I'm going to use equation number 2. So from equation number 2, I'll plug in the x value, which is 4. So 2 times 4 minus 3y equals to -13. You can choose any of the equations. Definitely the equation number 2 that we had, equation number 1 that we had was a better option in terms of lesser working, because I see the coefficient is just -1. Anyways, let's say we have chosen this equation. It's just a matter of doing the inverse operations correctly. Your subject is y, whatever is added, you'll subtract from the other side. So -3, -8. Your subject is still not alone. It's multiplied with -3, so you will divide by -3 both sides. I'm doing it all in one go. So y is equal to -21 over -3, which is positive 7. And hence, xy is equal to 4, 7. Remember, whenever we are solving simultaneous equations, we are basically finding their points of points of intersection. When I said points in the plural, it means if we have a curve and a line, then they may intersect at more than one places. So point or points of intersection. In this case, we have two lines. Both of these equations are representing some lines. So this is one point of intersection. But if it were a curve and a straight line, then they will be continuing further. Our question wasn't just finding the values of x and y. It says find the length of equal sides. Your answer must be not contain x or y. So we have got the values of x and y. We want to find the length of just the equal sides. These are the equal sides: x plus y plus 1, 3x minus 2y plus 14. I know they are going to be equal. So I would rather use the values of x and y here because working is less. X is 4, y is 7. So the length of equal sides is x plus y plus 1, which is 4 plus 7 plus 1, and that's a total of 12. The equal sides are 12 units in length. But let's say we want to verify. Someone chose this for finding the length of equal sides. 3x minus 2y plus 14, 3x minus 2y plus 14, and we will plug in the values of x and y, where x is 4 and y is 7. Let's see what we get. 12 minus 14 plus 14. Clearly, you can see that these cancel out, and 12 is the answer again.